All right, welcome everybody to another Rust stream. Been trying to get into the habit of doing this on a regular basis, and the past two Fridays I did some streamings on kind of specific Rust topics. Today we're going to switch it up a little bit and start doing a project that I need to get done anyway, and I thought, hey, why don't I just go ahead and stream while I'm working on it so that others can see, I don't know, a project being built from nothing. Instead of just kind of a contrived example. So hopefully this is helpful for people. I hope that we'll be able to make good progress today. I highly doubt that we'll be able to get the whole thing done. Probably going to be streaming for about 2 hours or so, and then call it quits for the day. And before we get started with that, I'm going to describe a little bit about the project itself. What it's for, why I'm doing it, to give some context to the whole thing. So hopefully that's helpful. And of course, chat, keep me honest. If there's something I say that you don't understand or something like that, then please ask. The aim for this stream today is to be relatively followable by basically anybody who has programming experience, even if you're just starting out learning Rust. Hopefully there's nothing here that will be kind of too over the top or too advanced. It should be relatively straightforward, but of course chat, ask any questions that you might have about that, and we will make sure to get those answered. All right, so switching over now to my browser to talk a little bit about what we're going to be working on today. So a couple of days ago, I tweeted out about a project that I had just I've been working on with a coworker of mine. By the way, I work at Microsoft, so that's why this is under the Microsoft GitHub label here. And the project is WinRT Rust. So you might notice I'm on a Mac. I am not a Windows programmer at all, despite where I work. But I've been doing a lot of Windows programming lately, and it turns out that it's actually quite interesting and a lot of fun. And this project has been quite a lot of fun to work on. So what is the Windows runtime? Basically, kind of the short of it is that it is a way for calling Windows APIs. And the reason that this exists is Windows itself is very old. As far as software goes, it's really old, going all the way back to some APIs that Windows exposed go all the way back to the 80s, early 80s at that. And if you try and count up all the different APIs that Windows exposes, it turns out that it can be upwards in the millions of different APIs that it has. So back in the 80s, when they started working on this stuff, the way that they decided to expose their APIs was kind of as flat C-style APIs, which is kind of the norm back then, and a very sensible way to expose things, and the way, frankly, that Linux, for instance, still does today. And that works pretty well, especially if everybody's programming in C, right? But when you get to wanting to use other languages that might have kind of richer or different type systems or object systems from C, then you might run into an issue where you're coding one way and then you come to call into an API, and it turns out that it's completely different flat C-style API. And so the Windows runtime basically is a way of exposing these types of APIs in a more, I guess they would call it object-oriented sense, but we've mapped it to Rust, which is not really an object-oriented language at all, and it feels quite at home there as well. So it is object-oriented in the sense that you have kind of things that you would call objects, and you can call methods on them. That's basically what object-oriented means in this sense. There's not really a sense of kind of deep, rich hierarchies of where you inherit from one class or another or something like that. It's kind of a little bit simpler than that. but getting ahead of myself, this is just a way of exposing a lot of the Windows API in a way that is not kind of a flat C style API surface. So what can you use this project for? Well, you can basically use it to call a large swath of Windows APIs for doing anything that you would do on kind of like a desktop operating system, like, you know, creating apps. So there's APIs for doing a whole bunch of stuff like drawing to a window, and all the way up to kind of modern things like doing machine learning and stuff like that. And the cool thing about it is that all these APIs are described in kind of language agnostic metadata. And this project, what it does is it reads that language agnostic metadata and generates, hold on, my screen's about to turn off here. Make sure that doesn't happen. All right. It generates Rust code based on this language agnostic metadata. And it turns out that the code that it generates is relatively-ish straightforward. And so you can see an example of it using here, like there's an XML document API, for instance, for parsing XML documents. And so you can see this is all generated. Nobody wrote this XML document Rust API. It was all generated from language agnostic metadata. And so you call XML document new, and then a lot of these APIs can fail because at the API boundary surface between the Rust code and what is most likely C++, because most of these APIs are probably implemented in C++. There's possibility for failure there if some things go wrong. So you're going to see a lot of question marks here. But then you just call methods like you normally would in Rust, like load XML, and you can get the document element, blah, blah, blah. And so this should probably feel relatively kind of rustic to you, but it's all generated from language agnostic metadata. And if you want to see what you can do with this, then here is a coworker created a clone of Minesweeper, or kind of a modern version of Minesweeper. And by and large, this is implemented using WinRT Rust. And so if we jump into the code in main here, you can see here we're kind of importing a whole bunch of Windows APIs, like collections and numerics and composition for doing graphics and stuff like that. And then there's a little bit of setup here that we don't have a good answer for how to kind of package this up into a nice, you know, at some point there will probably be a crate where it's just like, you know, initialize, you know, everything, a window or whatever. We don't have that yet because we don't want to really commit to that, but definitely encourage the rest of the community to take a look at that and come up with things. And, you know, hopefully we can together come up with some nice API for just bootstrapping a Windows application. And then it's using things like WinIT, which, if you're not familiar, is an awesome crate for doing kind of cross-platform window instantiation and handling and stuff like that. And so we fully take advantage of that, which is great. And then, you know, this is all kind of WinIT stuff. But if you go into the actual logic of the whole thing, like here, minesweeper.rs is kind of where the meat of the whole thing is. You can see in here, this is all calling these rich window APIs for setting brushes and offsets and is visible, blah, blah, blah. So drawing to the screen here. And this all these APIs were generated by this WinRT Rust from metadata that's just present on any Windows installation. So that was a long winded explanation of what this is. Hopefully that made sense to everybody. And why it's useful. Basically, this is just another way of being able to create Windows applications. One question that I often have gotten in the past couple of days since we announced this is, how does this relate to the WinAPI RS? So it's somewhat confusing that Windows has been around for so long that it kind of has multiple API surfaces. One of them is the Win32 API surface, and that's that kind of flat C style API that I was talking about before, where you're just calling C style functions. And that's kind of, before 8 years ago or whatever, that's kind of how you built Windows applications before WinRT came out. But that still exists. Like, Windows can't get rid of anything. It cares a lot about backwards compatibility. So like that all still exists. And the WinAPI thing, is in general a way of, it's a hand created version of that of the Win32 APIs, which can be useful if you need to call into old APIs, and not every single API or every single thing that you would want to do in a Windows app is available through a rich WinRT API, and so you might have to use the old Win32 APIs instead. And so WinAPI is kind of a handcrafted version of that, which is awesome, and kudos to the people who are keeping up with that. It's really great. I think the thing is, if you can use WinRT, then that's what you should be using, and if you can't because you need some API that might not be available in WinRT, then you use WinAPI instead. So hopefully that answers that. And I think we might have one more question. So every call can fail, or does it have a notion of methods that can't fail as well? I think the assumption that we have right now is that every single call can fail. Now, whether that's actually true in practice is a very good question. I think it's probably not true in practice, but there's not really a good way to know whether a call will fail, because ultimately we're going over. I won't get into exactly how WinRT works, but it's for those that know anything about Windows, it's basically a wrapper around COM, and all of those COM calls have the potential to fail. Like, they return a result that can either be true or false, and we're basically, or not true or false, it can either be like success or any number of errors, and we're basically just always propagating that up. Maybe in the future we can get smarter about which ones can fail and which ones can't, and then remove some of that error handling that, for all intents and purposes, will never fail. By the way, this crate here is not on crates.io right now because it's still kind of a pre-release. We just wanted to put it out there, see what people think, get some feedback on it. There's been talk there's an existing WinRT implementation that exists out there that was in various kind of state of being done, and there was some talk with the developers there of potentially collaborating and then taking over the crate on crates.io, since this seems to be further along than that one is, and of course has people who are paid to maintaining it, which is great. All right, so I'm assuming there's no more questions. Then we can get on what the activity is for today. So for those who don't care about Windows at all, bear with me just for one more second. We're going to get out of Windows land really, really quickly. So if we go back to WinRT RS here, this is really great for Windows APIs. If you have another question, go ahead and just ask it, and I'll pick it up when you ask it. This is really great for Windows APIs, and kind of it's built into, we have a way, like there's a known location of this metadata that describes Windows APIs on any Windows 10 installation, and so like by default it can just go out and like grab that and be smart about what you actually want to use, and then generate the code for you on the fly. But WinRT is kind of, in general, is a way that you can build apps that don't interact with the Windows operating system, and there's a lot of people out there that create APIs that are kind of built on top of this Windows runtime kind of API surface. And the reason they do that is because WinRT gives you a way of exposing a language agnostic API surface. So like we have Rust that's calling into presumably C++ based APIs in the Windows, and that are built into Windows. But of course they could also be in .NET, they could be in JavaScript, like they could be in theory in any language. It just needs to be a language that exposes support for Windows RT, which is not that difficult to do. And so we want to be able to have the ability to author APIs. Maybe, hopefully eventually in Windows there might be built-in some Rust APIs as well. Who knows? And so we want the ability to give that opportunity. But then we need some place to publish the metadata where that exists. So we have an API, and and .NET can call that API as long as it gets a hold of the metadata that describes that API, and C can call it, and C++, and JavaScript, and whatever. As long as it has a Windows runtime implementation, and as long as it has a hold of the metadata that describes that API, it can generate code that can call that API. But where do you host the metadata? For Windows, built-in APIs, that's quite easy. You host it somewhere on the operating system in a well-known location, and whatever can just pull from it. But if you're some random app or whatever, you have to have a place, or even the Windows API wants to expose it in a way that's not kind of baked into the operating system, because we want to have different versions and stuff like that. And so where do you do that? And the answer as of right now is, in my opinion, a little bit weird, but it kind of makes sense coming from kind of the Microsoft perspective. That's as a NuGet package. And for those that don't know, NuGet is kind of a .NET, the .NET equivalent of crates.io, basically. And NuGet, can of course package up C# code or F# code or whatever, but it doesn't have to. And some packages just bundle up this metadata to describe these APIs. And so here we have Win2D UWP, which is basically an API for doing 2D graphics rendering on Windows. And this NuGet package only really it includes metadata to describe that API, and it might include some DLLs as well to kind of back up those APIs they might not be built into the operating system. But that's really all that they're exposing. And so this is where that metadata, that rich metadata, lives. And what we want to be able to do is to kind of fetch that metadata and generate the Rust code that is able to call the APIs that metadata describes. And so the ideal would be to somewhere say, I have a dependency on this metadata from this NuGet package, fetch that metadata for me, move it into a well-known place, and then WinRT Rust will know where to find it and will generate the Rust code based on that. And so the idea for today is basically to create a tool that does that. And the idea that I have in my head is that there's a place in Cargo.toml that is unchecked. It doesn't, Cargo won't complain if you write something there, where you can basically put in anything you want to. And we would have some kind of key that's like NuGet dependencies or something like that. And then we would have a Cargo subcommand where you say Cargo NuGet install or whatever, and it would know where to fetch it from, NuGet.org, download it, unpack it to a specific location that then WinRT Rust would know about, so that it could generate the Rust code for you. And so this is kind of a way of allowing that metadata to live where it has up until this point always lived. It lives on NuGet, but integrated almost seamlessly into the Rust workflow, where you just have to know Cargo NuGet install instead of Cargo install, and it should all just kind of work. Now, obviously the ideal would be that we would just package up some of these on crates.io and stuff like that, but there's a lot of these APIs, a lot. And so to have somebody who is responsible for always saying, oh, there's a new version of Win2D UWP, make sure that the crates.io version is up to date and stuff like that, is a lot to ask for. And so this is kind of a way of everybody wins. The people who are in charge of these APIs, if they don't care about Rust, don't know about Rust, whatever, they don't have to. Their stuff just goes where it's always gone, and our tools do the best to kind of work around that and pick up the metadata from where it lives naturally. Real quick question: the import macro is used by the user of the crate. Does that mean when I build Rust doc, I won't really see all the different APIs like for WinAPI? Yes. So WinAPI is basically definitions for all the APIs that exist for Windows. WinRT Rust is effectively a code generator. And so WinRT Rust doesn't really know anything about APIs that actually exist out there. It just knows how to take metadata and generate code based on them. The only thing it really knows about existing APIs is it knows, oh, there's a place on your Windows 10 installation where that metadata is described. And so I know how to fetch that and generate the code for you, but it doesn't know what that metadata will say at all. It has zero knowledge of that. And so, you know, how this will actually end up working in practice is a big question. Will there one day be a, you know, Windows 10, I don't know, like collections is an API that exists. Windows 10 collections, you know, version whatever on crates.io. That's basically just using WinRT Rust to read the metadata that that API exposes and generate the Rust code for it, and then basically it's just like a cache on crates.io. Like, that's completely possible. We're not doing that right now because that's a big commitment to have to like maintain hundreds or thousands of APIs on crates.io that this would expose. So we'll see, but yes, in reality, WinRT Rust doesn't actually contain any APIs. It's just a way of generating codes that rich metadata describes. Hopefully that makes sense, and it seems like it does. Okay, we're 25 minutes in, and I haven't done anything yet, so really got to get going. What the plan is concretely is we're going to create something a la Cargo expand, or if you know Cargo edit or Cargo add, or some of these Cargo subcommands. It turns out Cargo, if you Cargo install Cargo expand, and then you type Cargo space expand, what Cargo does at first, if it sees a subcommand it doesn't recognize, is it looks in your path for cargo dash that subcommand, and if it finds it, we'll just run that. And so if you have cargo expand on your path, then cargo space expand will just execute cargo expand. And so what we're going to do here, you know, that's all that we care about for cargo expand. We won't use it today, although it's an awesome tool. You should check it out. We will be following that same pattern where we'll probably do Cargo NuGet or something like that, which unfortunately exists on crates.io, so it's something we're going to have to figure out at some point, but we're not going to publish to crates.io today, so it's fine. We'll just create Cargo-NuGet, and that will allow us to do Cargo space NuGet with just using the regular Cargo, as long as somebody has Cargo NuGet installed. And we'll do Cargo NuGet install, and it will note where to look inside of the Cargo.toml file for the dependencies that you've kind of listed out, and it will download them and do the right thing, put it in the right place. So what are we going to do? We're going to be using StructOpt today to do parsing of command line arguments. The reason we picked StructOpt is it's on top of clap, which is kind of like the de facto command parsing library, and StructOpt is just like a nice derive macro on top of it that eventually will be brought into clap in the next version whenever that comes out. And I know StructOpt fairly well, I guess. I mean, I've used it before, I should say. I'll probably end up messing it up somehow, but I've used it before, so I'm familiar with it. So we're going to use it today to do the command line parsing. And then I think what we'll end up doing is using surf as the HTTP library. If you're familiar with Rust HTTP, then you might be wondering, why are we using surf versus using something like hyper? And the reason is purely, I don't know, I used hyper in other projects that I do for work, and I thought, why not use surf, because it seems nice. And I haven't actually used surf in a kind of a real thing before. I played around with it a little bit, but I haven't actually really gotten to use it. So I thought, why not? And if we end up not wanting to use surf at some point, switching it out for something else shouldn't be too terribly hard. You could argue we should use something that's synchronous by default because we're probably not going to do asynchronous stuff here, but whatever. We can make these changes later on. So that's the plan for today. Hopefully that makes a bit of sense. And I think we're going to get started. So if you have any questions about what we're doing, why we're doing it, anything like that, please let me know. And we'll go ahead and get started. So I'm going to start now by doing a new project. So we can do cargo new, and what do we want to call it? Cargo new, cargo dash NuGet. All right, and then I'm going to go ahead and open this up in VS Code. That's what I've been using lately. I keep saying that I've been using it lately. I've been using it for like a year and a half now, so I should probably stop saying that. And just to make sure that everything looks good, let's just go ahead and run it. And we get hello world. Awesome. So we're ready to go here. And I think that the first thing that we want to do is do create an install command. So we'll give a way to where when the user runs this, if they do cargo-NuGet space install, it will run our install command. So it will run whatever we want it to. And so I'm now thinking that StructOpt is maybe a little bit of overkill, but I'm just going to use it because I think if this thing gains more and more functionality, it's nice to have. We don't necessarily need it. Cool, so we can do StructOpt 03 here and put it in here. And then as you can see here, this is kind of how you define your options. So you create a struct, and it can be called whatever, and they call it op here. And then you define kind of the flags that go along with it. And so if we just copy this, and I think it uses the documentation as well to kind of create good documentation for it. Great. So like this, we're going to have opt. I think we call this NuGet here. And then we'll have our derive here, a utility for interacting with NuGet packages. I don't know. And unlike here, where this is basically flags, so like for instance, you have -c or whatever here for NB cars, then we don't want to do that necessarily right now. What we want to do instead is have a subcommand, and I think in examples they have a subcommand. Here's subcommand aliases. Where is it? Yeah. So here is an example of a subcommand where this is their top level struct, and then they have subcommand. So you annotate it as a subcommand and call it whatever you want. So we can do the same thing here, and we're going to call this install and install like that. And then we have to create a struct called install as well. Let's do it below. And I think for now we don't need anything in there. So this has described the command line arguments that we want to go ahead and take. And so I think the next thing that we need to do, if I remember correctly, is go ahead and call this from args here. So if we call from args here, then we'll get an opt that kind of describes our command. And now I'm thinking this isn't how it works. We don't want it to always be install. We basically want sub command like this, and then sub command, and then enum sub command, and this is where, you know, we say the various subcommands that we might have. And for now, we only have one subcommand called install, but you know, in the future maybe we have more. And I think I still need to annotate this like this. And so now our subcommand here will tell us what kind of subcommand do we have. And of course, right now we only have one, but in the future we might have more. So we can do, let's just do this real quick, where we print out the subcommand that we get. So opt.subcommand, and hopefully what that will do is print out install when we go ahead and run it. Whoops. So if I run cargo run -- install, oh, that's not good. What's going on here? We got some kind of linker error. Undefined symbols for x86-64. What? Well, this is strange. Yeah, we are running unstable. This is very weird. I've never seen this before. So sorry for those who are. What is going on? And if we do, is it because of StructOpt somehow? Bring back our main here. Huh. That is very strange. I think when I run into interesting things like this, I like to just like blow away my target folder. I don't know. Because sometimes that helps. And then just like hope that it works. And we'll see. Yeah. No idea why that happened. If somebody figures out what I did there to cause that to happen, let me know. Something strange. Yeah, I don't know. So we should probably bring this back now and see if we get the right thing. Oh, we don't have StructOpt, so use StructOpt, and that hopefully brings everything in. Looks like it. There we go. Great. So I think chat was asking, how did I fix the issue? The trusty old delete everything in your build folder or your target folder. So of course everything, if you see down here, when you build something, it will go into the target folder here. And if you end up with something weird, where especially some strange linker error, I have seen this very rare occasions where something gets confused. And usually the best thing to do is just clean the entire thing. So what I did was rm-rf target. I could have just deleted the whole thing. and that seemed to fix it. So built it from scratch and worked. I don't know. Who knows? Who knows? Okay, so we're good to go. We know that when cargo install gets called, what happens if we call like this? We get our help menu, which is why we're using this thing, which is nice. And foo, argument foo was not expected. So I tried cargo clean and it also didn't work. So as far as I'm aware, cargo clean is not exactly the same as just rmrf target folder. It does do something in addition to that, but it gave me a weird error and I said I don't have time for this and I just deleted it. So that seemed to work. I don't know. Who knows about these things? All right, great. Where are we? We are successfully running our thing where we actually get the install command. So I guess what we can do now is say opt, this is a little ridiculous, but like opt sub command, and then it's install like this. And of course, that's the only thing we can get. Otherwise it would have errored. And so in here, like we can say like perform or do install. Great. So now we're going to do install, and this needs sub command : and do install doesn't exist. So let's come down here and create do install for now, like this. And let's think a little bit about what we want to do here. So what does installing mean? It means we want to read presumably we want to try and find a Cargo.toml file. We want to parse it. We want to look for a special key that we will have in there that's is our NuGet dependencies or whatever, and then go one by one and download them all, and then then we'll talk about what we do after we've downloaded them. Okay, so the first thing that we need to do is find a Cargo.toml file. I think for now the heuristic we will use is a Cargo.toml file should be in the current working directory. So wherever the person is running the command from, we're going to try and find a Cargo.toml file there, and if it's not there, we're going to blow up. Is that the best solution ever? No, but we're going to do that from now because it's definitely the simplest thing to do. So how do we do that? Let me go ahead and close some of these things here. The first thing to do is look at the standard docs and here, and inside of FS I think is a good place to look here. And I think what we want to do is read dir here, or we can just go ahead and try and read it. That's probably the best. Now the question is, do we want to... So the thing I'm thinking in my head is, do we want to use standard FS read dir, so the standard way, or standard FS read or whatever, the standard library, or do we want to use something like async standard, which would be the async choice for now because we're going to use surf, and surf runs on top of async standard. Tokyo being another popular one. So if you want to use hyper instead, you might more lean towards using hyper Tokyo. The question is, do we want to use that? We're going to bring in an asynchronous runtime no matter what, and it's totally fine to do blocking outside of our asynchronous context, and then when we need asynchrony, do asynchronous programming. But a good question is, why don't we just go ahead and do async the whole time? But you know what, we're not going to do that. We're going to just use the regular standard library for now, and then when we absolutely need, to do asynchronous programming, which is when we're using surf, then we'll go ahead and create an asynchronous runtime. And question from the chat: aren't asynchronous files really slow, like much slower than blocking even? I'm not sure. I know that async files basically they're not really like files aren't async. Most operating systems don't provide asynchronous APIs for file handling, and so what most async runtimes end up doing is having kind of a built-in thread pool for doing these operations. And does that end up being slower than it would otherwise? I have no idea. Doesn't really matter for our use case. Speed is not what we're going for here. We're just running a simple thing. As long as it's not incredibly slow, we're really not trying to eke out every last bit of performance here. Okay, so let's go ahead and read our Cargo.toml file that we're just going to assume is where we need it to be. And what we can do is just do Cargo.toml like this. And yeah, let's go ahead and return a result here. So yeah, let's do this. Std.io result, which just hard codes the error to be an IO error instead of you having to provide the error. And we're going to return unit from this. All right, so now we can do our nice question mark here. What is it complaining about? Oh, and we have to, everybody's favorite thing that all the blog posts have been about lately, the explicit wrapping of our unit here. Okay, so we're going to read the Cargo.toml file. It's complaining about here. We want to for now, we'll just go ahead and unwrap. We can clean that up in a little bit and say, you know, some nicer error handling for that, but for now we'll just crash. If the Cargo.toml file is not there, and this gives us bytes here. So we need some way of taking these bytes and making sense of them. So we want to read this Cargo.toml and have some kind of representation of it as a Cargo.toml file, or at least a toml file. But I believe, if I remember correctly, that there is a crate out there for parsing Cargo.toml files. Yeah, Cargo.toml. That looks good. Cool. Documentation. So this crate defines structs that can be deserialized with Serdic to load and inspect Cargo.toml metadata. That's awesome. Cool. I think that's what we want. So yeah, manifest is the top level structure that you have here. And yeah, we can even pass in a slice here, which is what we're going to get back a vector, but we can easily turn that into a slice. And it will either give us a result or an error. Perfect. So we want to add Cargo.toml 08 to our file. Here, Cargo.toml 0.8. And nope. Oh, is it Cargo_toml? Yes. Cargo_toml? Yes. Cool. And so now what we can do here is say, I'll do it up here, use Cargo.toml manifest. This gives us the manifest that we want to go ahead and parse, and we can say manifest.from slice, and then we pass in our bytes. And I don't think this will is it going to dereference? Yeah, it will, hopefully. Cargo check is taking a while. One thing, oh, it's added a new dependency, that's why. But also streaming for me is definitely slows my machine down. So see if there's any questions. Is that sufficient for extending the format? Ah, that's a good question. So we want to, we're going to have a slightly extended version of Cargo.toml, because Cargo.toml, and I think we can look this up, Cargo.toml manifest, and see hopefully the manifest format. Awesome. I like it when DuckDuckGo works the first time. Doesn't normally, but there is it's metadata. So the metadata table inside of Cargo.toml, Cargo will default warn about unused keys in Cargo.toml to assist in typos and stuff like that. That's awesome. But the package.metadata table is completely ignored. And so anything that you put inside of package.metadata just gets ignored by Cargo, which is great because we can add stuff to it. And so the question from chat is, does this crate do the right thing and just give us, I don't know, like a raw representation that we can deal with? So it's package. Let's look here, package. And then it looked like metadata was, yeah. I think, where is, yeah. So it looks like we can just pass in anything that is a cargo.toml file, which hopefully, yeah, I think it will work. So, oh, and there's a question from chat. What gives the thumbs up? Yeah, it's called crates, I think. Where is it? Where is it? Crates. Yeah, this one. Crates by Sere Uzgar. Gives you the thumbs up if it's the latest version of a dependency, and a little thumbs down if it's not, or a exclamation point if it doesn't exist at all. Cool. Great. So it should be, hopefully this should work then. Everything should work. First of all, we can propagate our error up from parsing here, although actually it won't be there's no conversion there. I don't feel like doing error handling right now. Error handling is something that people have asked about covering, so we can do that a little bit later on, because it's nice to talk about different error handling strategies and crates that we can use. Question, am I using RLS or Rust Analyzer? I'm using Rust Analyzer, which for me has been much better than RLS was in terms of reliability. So I'm quite enjoying it. I think definitely recommend using Rust Analyzer if you can. It somewhat falls apart in async code, or at least it did the last time I was using it, although now I think they have better support for associated types, which was kind of keeping it from working well. So we'll see. I haven't done any async programming in the past couple of weeks, so and that support just came out. Ooh, there's a manifest from slice with metadata. Really? From slice with. Okay. Parses Cargo.toml, parses its package.metadata into a custom Serity compatible type package. That's a good question if we want that. Do we want to? So the whole thing with this here is that we want other people presumably might be using this, and so we want them to be able to continue using it for their own thing, and we only care that our thing works as well. I'm not sure. Let's try without the from slice with metadata and see what happens. Maybe we move back to it. I don't know. We'll see. Great. So now we want to let's run this. I think parent. I think that manifest implements debug, which means we can kind of look at it and we can run it on our own Cargo.toml for this project, which is great for testing. Manifest. Oh man. All right. Let's run it. Oh, it takes a while. I guess because we just added a dependency. Great. Cool. So I think, is this the syntax? Should be able to do that instead, and it will give us pretty printed. So that's a little trick. If you want to get pretty printed things, that works quite well. Great. So if we go into our Cargo.toml here and we say package.metadata, and I think if I remember correctly, yeah, so it could be like package.metadata.android. I'm going to test it that it has like, you know, foo equals bar. So that should still work. And we want a package.metadata.NuGet. And I think camel case is what is normally done for these. If it's not, let me know. Dependencies, and then we want to have like let's go whoops, when to so we want to do something like when 2D UWP equals, and I think I can do it like this. And the latest version was 125.0. Okay, and so if we run this, then and my looks like the crates thing does not do the right thing, which is kind of funny. Could not parse as toml, so that's why it's complaining, maybe. Is it? Okay, that works. Actually, yeah. Is it the dot there? Maybe it's the dot. We'll see. Nope. Is it this? I feel like chat is probably screaming at me right now, and I'm not looking, which is not a good idea. There we go. Okay. And then presumably this isn't needed. Cool. So we can look at our metadata then here. How does it show us our metadata? So some, okay. And then it's a table. And then Android and NuGet dependencies. Cool. So this is probably not completely the right thing. But we want to say NuGet deps equals manifest dot metadata dot unwrap for now. And again, we're just really not doing the right thing when it comes to error handling. And then I don't know how to access a value from so we should have value here, and then values. So we're gonna pattern match on the value here, I guess. So let's call this metadata, and we're gonna say match metadata, And if it is a table, that's great. And otherwise, we're going to, for now, panic. Ain't no table. Cool, and then we can do t here and get out the NuGet dependencies. This is obviously fairly nasty code here, but that's fine for now. This will, if we match here, then this will be another, and of course this will panic if NuGet dependencies isn't there at all. And then we want to have, oh, table is not the right thing. What is it called? Value. Value. And then we want value table. And this gives us our deps. And otherwise, for now, we can panic. Not there. Great. And here, let deps is this. Definitely miss. Am I missing? No. Oh, I'm inside of my match here. Ugh. Do not want that. And sometimes I don't like when it rearranges the whole thing. See? Why do you do that to me? Great. And now it's complaining that metadata doesn't exist. Doesn't it? Well, let us see. Oh, it's package, sorry. Which package is also an option. Great. Dot package dot unwrap dot metadata dot unwrap. It looks like pancake. Manifest.pancake. All right. Let's see. Anything from chat here, I guess? Yeah. Yeah, this parsing is not exactly ideal. This is super rough. I'm just trying to get it to work as fast as I can without thinking too hard about it. So it looks like we are moving the deps out from the table. Do we want to, for now, we should just be able to do that to get a reference to it instead. So now deps is a reference into our metadata. We can clone it at some point if we just want to stop dealing with that. Great. Cool. So this is good. We have, I feel like we can take all this and move it to like a get deps that takes a manifest, and it will take a reference to a manifest and return a reference to a hash map of string and value, if I'm not mistaken. Yeah, just deps. Of course, standard collections hash map, since it's not by default there. Oh, and it's a TOML map. Of course it is. It's a TOML map. I hope I don't have to bring in another dependency just for that. That would be unfortunate. Where am I? Here. Package, metadata. Oh, it's value, sorry. And value, and it's a map. This is TOML map. Is there a way to just turn it into a hash map? No. Bummer. Oh well. And I don't believe Cargo.toml re-exports TOML. So it looks like if we want to do this, we are going to have to take another dependency. I mean, we already have a dependency on that thing, but now we have to explicitly take a dependency, which is fine. So we want TOML 5.3, I guess. TOML. And hopefully that just works out. And now we can do use TOML map. No, map. Use TOML map. And then this is no longer a hash map, it is just a map. Oh yeah, that's true. So just for those that aren't aware, we're calling manifest.package unwrap, and that will get a we'll take ownership of package, but we can't take ownership because we only have a reference here. We can do something like this where we turn it into a reference the whole time, which is kind of ugly, but we're saying get the package, but don't give me the package itself. Give me don't give me an option of the package itself. Give me an option of a reference to that thing. And so we're still going to always be pointing into this manifest, and this then works. So this will give us our deps. So then now we can do get deps on our manifest like this, and we can go ahead and print line. Let's do the same thing. Hopefully this works, where we can do deps here, and hopefully we don't need to see that anymore. Hopefully we'll see what we expect to see. Cool. So now we see our table here, where we have our dependency. Ooh, that's interesting. That's how TOML works, I guess. Yeah. So this will, because it has a dot in it, it needs to be a string like that. Yeah. Interesting. I'm curious. I guess floats or whatever don't work in TOML. That's why that doesn't work. Okay. Cool. So now we have our dependencies. You know, I know I made it this whole hubbub about bringing in another dependency to get this map, but now I'm thinking we should just have a vec of tuples with the name of the thing and the version. But maybe that's not what we want to have, because eventually we want to support other configuration, like being able to, we're going to assume for now that this is all coming from NuGet.org, but maybe in the future we'll allow people to specify other NuGet repositories and stuff like that. I don't know. We'll see. So this is fine. Okay. So things are going a bit slow. Sorry for that, but we are doing pretty well. We have parsed our Cargo.toml file. We've gotten the dependencies from it. So now what we want to do is take those dependencies and download all of the NuGet packages for those dependencies. And so what I feel like we want to do is turn this map or whatever into like a vector of dependencies or whatever. So we could have some kind of struct dependency here where we have a name and we have a version. And I mean, if we wanted to, we could do something like this, I guess. You know, major, minor, super minor, or whatever they're called. But for now, we'll just do a string because that's easier. Dependency. And so, yeah, let's do that. I'm just going to return back a vec, and this completely destroys the whole thing I did with getting toml as a dependency now. That's fine. Let us introduce derive debug on this so we can take a look at it. So now we have these deps, and what we want to do is say for, hopefully this implements iterator over the key and value. Let's see. What is K? Why is it complaining? Yeah, that's fine. We can do here to get it to shut up. Oops. So this will give us a key. So we'll assume the key is a string, and so that's good. We'll assume that the key is the name. Let's just call that name. And then value, we want to match on value. And if we only want to do something if it is a string. So again, sorry for the horrendous error handling right now, but at least we know where we need to handle errors. We only expect something for a string. And this will be our, let's call it version. You know what, I like doing this key value, and then we'll match on the value, and that gives us the version here. And otherwise, we'll panic again because we're not handling errors right now, we're just crashing all the time. So version was not a string because it needs to be a string. Maybe at some point we will allow numbers as well for the odd case that you only want to specify like a major number or something. I don't know, we'll see. So this gets us the value. And the version. And then we want to build our dependency where we say name is key and version is version. And you know what we can do? We can just go ahead and do deps.iter.map where we get the key and the value like this. So we're switching this from an explicit for loop to a map here, and then we can call collect on it like this. We are getting, because we're only dealing with, you know, I'm just redoing all the code that I did before. But but we learned some stuff. So we're going to take ownership over manifest so that we can like rip stuff out of it. So we don't need any of this. Now we're taking ownership over it instead of taking a reference to it. That's fine. So that we can get stuff out of it. So key here, we can call depths. So iter here will give us an iterator where it iterates over and gives us references to the things inside of the collection. What we would like to do instead is iterate and get ownership over each thing in turn in the collection. And so the way to do that is to do into iter here. That I would have expected that to not be that, but we'll see. And then version, what is it complaining about here? It's also a string. I would expect these to not be references. Yeah, it's giving us references. Why is that? Because this is ref. There we go. So sorry, what I did, let me explain real quick what that was all about. Before I had ref here, and what that means is that instead of getting ownership over depths here, I was just getting a reference to it. So basically a pointer into depths. And so into iter here, no matter what, it can't give me ownership over the things because all that depths was a reference to the thing. And what I really want is saying, like, give me ownership. At each of these steps, I'm like taking ownership over the thing. And so into iter here will give me an iterator where I get the ownership over the key and the value, which is exactly what I want. And now the thing is complaining, collect is complaining because it's like, I don't know what you want me to collect into. And hopefully if we remove this and this, it will now know. So now collect knows it needs to collect into a vector because that's the return type. All right, so now we have a vector of dependencies. Debugs is not a thing. This is why can't I move out of index. How do I get ownership of, I think it's remove, right? Probably. I don't know, this is a weird map thing, so remove, yeah. So indexing by default just gives you a reference to the thing, so it doesn't like rip the thing out of the collection to hand to you. It just says, hey, it's over there. It gives you a reference, a pointer to the thing in the collection. Say, this is where it is. It's in the collection over there. And we don't want that. We want to rip the thing out of the collection and take ownership over it. And the way to do that is to call remove like this. And what remove will do is literally rip the thing out of will rip the thing out of the collection. And of course, now remove returns an option. Before the indexing was, if it wasn't there, it would just panic for us. Now it's not doing that. We explicitly have to handle that case. And so that's why I had to wrap it in some. And the last thing is we are trying to mutate t, but we didn't say that it is mutable. Okay, now don't do that. Now let's run this thing and see what happens. Great. Now we have a vector of dependencies. We get a name, we get a version. So that is wonderful. I'm going to stop real quick and pretend to drink water, even though I don't have any. And I want to ask if anybody has any questions in the chat or anything like that. We went somewhat fast there. I don't currently see any questions. Just want to ask, is anybody confused about what we're doing, how we're doing it? If there was a piece of code that you didn't understand that I wrote, now is the time to ask. Otherwise, I assume this was 100% clear, which I went really fast. So, and I can't imagine all of you have done a ton of Rust before. So it's totally understandable if somebody does not understand a piece of code. Feel free to ask. Otherwise, we will keep going. All right. I'll assume we're good there. Just let me know if something occurs to you. Oh, quick question. So it seems we have somebody new who has joined the stream. What tool are we building? I spent about 30 minutes going over that before, so I can't give you the full answer. But the short of it is for some strange reason, what I need to do is download NuGet packages. And I want a way of specifying those NuGet packages in my Cargo.toml. And it turns out that Cargo.toml has a place where it can allow arbitrary data inside of package.metadata. And so we are parsing our Cargo.toml and getting this information here, and we're now going to download the dependencies from NuGet.org. So why we're doing that is I'll chat if you want to help me out with that. But that's kind of exactly what we're working on. Great, so we have our dependencies here. What we want to do now is go ahead and download them. So we need to basically form URLs and download our dependencies. So I think what we'll do is something like download dependencies, where we pass in our dependencies. And notice if I were doing this not in front of people, would I clean up a little bit more? Yeah, because I wouldn't be talking so much, and maybe I would have a little bit of a better idea of exactly where I want to go. But it's fine to just kind of go down the file and just keep adding stuff. We don't need to have it in a perfect structure right now. We can clean that up later. So our deps are going to be a vector of dependency. And now what we're going to do is download them. So I guess the first thing we can do is turn our dependencies into a iterator of URLs, because I think we have all the information from the dependency itself to turn it into a well-formed URL that we need. So if we do impl dependency here, URL, and let's just have it return us a string, and this is going to return the URL string that the dependency can be found at. And so if we take win2d.uwp as an example here is the raw download package if you just want to get a raw link to it. And it seems like we just need to have this prefix to our URL here, the name of the package and the version, and that's it. So that's pretty easy. We just want to do format boom, 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 where the first one is going to be self. And of course, I need self here, self.name and self.version here. And this will format a URL string for us. So that's great. That was pretty easy. Then we can call like map or whatever on our, we can do our URLs and do deps.iter.map dep.url like this, and now we have a URLs iterator here, so we have an actual iterator to the URLs that we want to download. Great. So now I guess the thing that we need to do is to go ahead and actually do the downloading, and that's where Surf is going to come in, that we looked at before. So let's look at Surf real quick. And again, we're using surf because I just wanted to give it a try. This is what surf looks like. So we're going to want this. We need async standard as a dependency because that's what surf. That's the asynchronous runtime that surf runs on top of. And we're gonna take advantage of this block on, which basically takes an asynchronous block and blocks the current thread until that whole workflow finishes. Luckily, though, like the actual workflow that we're going to be doing will take advantage of it being asynchronous, and we'll be able to download all of our dependencies in parallel, which is pretty cool. So the first thing that we need to do is add async standard and async standard as a dependency. 1.0 might be good, but maybe not 1.5. Okay, never mind. 1.5 and surf is, I think there's a 2.0.0 alpha 1 or 2 or something like that. Let's see, that's probably going to complain. Oh, I should close this. Or maybe it's not published on crates.io. Whoops. Yeah, 1.03. It should still work though. 1.0 like that. So there was a question: wouldn't async standard be brought in transitively? So yes, it's brought in transitively when we bring in async surf. Surf itself depends on async standard, but we need to explicitly call async standard. If we go back here, we're going to be calling it just like this, and task comes from async standard. And in order to use, it's not good enough in Rust. You don't. If you use a dependency explicitly, if you use like the actual API itself, it's not good enough that some other thing has transitively depended on it. You need to explicitly declare that you depend on it. So hopefully that helps. Cool. Great. So then we can just gonna put this here for now. We can just go ahead and copy this here, where we're going to. And in the spirit of just really not handling error handling or thinking about error handling at all right now, we're just going to unwrap around this thing. Great. And so in here, what we want to do is in a somewhat similar to this, but we want to call urls.map where we get the URL. Oh, we can't do map, unfortunately, because we're going to call something async inside of it. So we need to do a for loop here. So for URL and URLs, we want to do something like this. And I'm thinking now we need some way of relating back the contents that we get to the dependency. And so we might, instead of just getting the URL here, we might want to do something like this, where we get the, let's not do this. Let us do for deps. And for dep and deps, we're going to call dep.url like this. This will get us the result here, the response. And let me go to the docs real quick. And we want a response. And there should be some way of getting body bytes. It seems like what we want is just the bytes here, like this, because we're going to have to unzip because NuGet files at the end of the day are zip files, and so we really just want to have the bytes of that file. There was a question in chat, why can't we async inside of map? Because the closure that gets passed to map is not itself is not asynchronous. We could inside of call it inside of map, but what we would do is be mapping over the thing, and then we'd get an iterator of futures, and then we would need some way of collecting all of those futures. You know what? Let's do that. This will be good. This would be good to show people. So we're going to call map here dep. And then because we need to do async stuff in here, we're going to put this all into an async block like this. And now it should be fine to call asynchronous things in here. So this gives us a response. Then we want to call res.bodybytes await question mark. It should be .await. And then we can put that inside of the thing here. Great. So now what we're getting back from here, of course we can get rid of all this. So what we're getting back from here is just an iterator of futures, and futures in Rustbot, when they're doing nothing, when you just create a future, it doesn't do anything. Futures are innate. This is not like JavaScript or something like that, where there's some background runtime that's constantly pushing things forward. There's nothing ticking away here. You have to basically submit your future into the runtime in order for it to run. And so we're creating a bunch of futures here, but we're not actually submitting them back into the runtime for it to be actually run. And so what we want to do is we want a way of saying, I have a collection of futures, give me back all the results when all of them are done. And so if I can, I'm trying to think what, and chat is saying, isn't there a futures.all? That's exactly what I'm trying to think of. There is a function, there definitely is a function that allows you to give it a collection of futures, and it will wait on all the futures until they are done. I just cannot remember where this thing is. We should first look inside of docs.rs async standard, since we're already depending on it, and see if there is some kind of and it might not be in here, it might be in futures, the thing that we're looking for. And I think it's this, join. Although join is not exactly what we want. Join is if you have a kind of a known number of if you have a known number of futures that you want to await, but we have an unknown number. We don't know till runtime how many how many things we're going to be downloading. Oh, I wish I could remember this. Oh, what is it? This is it. Yeah, exactly. Join all. Yeah. So here it is. Creates a future which represents a collection of the outputs that the future is given. And you can see down here, foo right here is just is an asynchronous function, so it returns a future. And so when we call join all on these futures here, it will give us back. It will wait on all of them. And the only thing that I want to be 100% sure about is that this does not that this doesn't wait for one to finish before going on and trying to finish the next one. The return future will drive execution for all of its underlying futures. Okay. No, I think this is fine. This should work. The unfortunate part about it is that we need one extra. It's not that we're already depending on futures transitively, so it's fine. But we have to have one more non-transitive dependency. And join all might be available. Futures is kind of a collection of dependencies, and so there might be a more efficient way of getting this, but that's fine. For now, that we can just do this. Futures join all, and we can pass in our let. Cool. Oh, and of course we got to call await on this, or otherwise it won't matter. And you can see here, it seems like what's futures? Futures future. Of course, futures future. And this error that we're getting here is because we don't know what type of error that we expect. I believe if you look at body bytes here, for instance, what type of error it's returning. It is returning an IO error. Interesting. But this surf.get will, sorry, I just lost chat there because I went back on the wrong browser. Sorry about that. If you asked a question, I apologize. You might need to repeat it. Let's see, surf get returns back a interesting. Seems like surf get doesn't return an error. So I'm wondering why this is interesting. But it looks like it is returning an error. For some reason this is not. Not sure why that is. So we need to just say what the error is. I think the best thing to do is to say that, and this is a way of just saying what type of result that we're returning. So figure out what the OK type is, and the error type is going to be box. I wish that there was. Oh, I did it again. Got rid of chat again. Box stood error. We can see how far this takes us. Oh no. It's not. unmatched angle break. Oh, that's because this. And now we can see that it is an error and send and sync. That's very ugly. And I guess this is the same. Oops. We can go up here and say type error is, oops. Oh, come on. Type error is all this stuff here, so we don't have to keep repeating it. Okay. So it looks like it's not happy that we are borrowing dep here. So we want to move dep in. Async move just means instead of trying to borrow here, just like closures, async blocks are very, yeah, they're a little magical in that they try and figure out the minimum invasive thing to do to get things to, they want to do the least amount with ownership, so they try to borrow if they really try to borrow, and if they can't borrow, they'll return an error. And move means no, don't borrow, move the thing in. So now we're moving it in. Great. And then this is great. We have iterated over our deps. We've mapped. We're doing async inside of map here, where we're getting the URL, we're calling it, we're downloading the result, we're getting the bytes, which might take a while, and then we're returning the bytes, and then we're getting all the results here. So this is where Rust Analyzer is not quite perfect. It doesn't know what results is here, unfortunately, but results here should be, I believe, a vector of results of vector of bytes, basically. And so I think what we can do here is just return this. And interesting, block on inside of async standard docs.rs async standard block on should return the result of the future that we're returning from inside of here. So it should return, you know, an okay here. Oh, it's because of this. So now we can say, hey, you said up here that you're returning an empty tuple, you're returning unit here, but I'm getting a vector of results here. And so we should be explicit and say we want a vector. Let's just actually say we want a vector of vector. What do we want here? We want to return the dependency. We will return a vector of dependency to the vector of U8s. So this is basically saying, give me a vector where with a tuple, where each element is a tuple, and the first element in that tuple is the dependency, and the second element is a vector of U8s, which will be the value that we've downloaded from NuGet.org. which is totally not what we're returning. What we're returning right now is a vector of results. So basically what we want to do, I think the first thing that we should do is if you have a vector of results, but you want a result of vectors, you should be able to do collect. Where collect can be smart and say, oh, I know how to turn an iterator of results into a collection that's inside of a result. So kind of like inverse the whole thing. And we want to say this is a result of vector of U8 and error. And one thing I like to do is write to do down here to sometimes the errors that you're getting are too much because it's like you're doing a lot of things wrong. To do can be nice to kind of say, like, past this point, trust that I'm going to do the right thing. Let's see what it's saying. And this is kind of a hard error message to read, so a good thing to do in that situation is do cargo check, so that it gives you a little bit of a nicer error message. So it doesn't know how to return, can't build a result of vectors of U8s from an iterator of vectors of results of vectors of U8s. That's the issue here. We've got vectors and vectors and vectors that are happening here. What we want is a and it's saying now I am getting a see if I can get this to work real quick. We might have to, I think, so basically what we want to do at some point is just we want to we don't want to deal with these errors right now. So I think the easiest thing to do is just return this results here instead of wrapping it up, instead of saying that this is going to be a result here. And that's actually, oh, that actually works. Nice. This works because we have one less result to deal with. I think whenever you're running into like types on types and types on types, it's nice to just break things up so that you know how you're building things up here. And so it bears repeating, what does this represent here? And in fact, I don't know if we do this, what do we get? We just why is it not? Oh, helps when you hit the right method. Yeah, so this now, if we don't do the iter dance, we get a vector of results, right? So again, just to step through the types real quick of what's happening. Results here is an iterator of where it's either a byte vector or an error. And so when we call join all here, results here is, and I can just write it out, is going to be a vector of results of vector of U8s or error. And so we've got vectors on vectors and vectors and stuff like that. But this vector right here is the bytes. And we might have errored out getting those bytes. And we're getting those bytes for many different things for each dependency that we have to get them for. And so that's what's being returned down here is this vector of results. And what we want instead is to say, I don't want a vector of results. What I want is a result of vectors. So like, can you please turn that inside out? And it turns out that collect knows how to do that. So collect can take a vector of results and turn it into a result of vectors. And so you will notice that these are just, this result and this vector are just swapped with one another. And that's exactly what's happening here. And then we're unwrapping for now, but that's fine. And the last thing that that I will complain about here is that, you know, you said you wanted to return a vector of tuples of the dependency and the bytes, and you're just returning back a vector of the bytes. You know, that's what we set up here. We want the vector of tuple of dependencies and bytes. So we need to, I think the best thing to do here would be to turn this into iter here. This from going from iter to into iter means that we will get our dependency now. We'll get ownership of our dependency instead of getting a reference to our dependency. So that's good. And now we can return back our dep along with our bytes. And of course, this is all, that's wrong there. And I'm just doing underscore to say figure it out. Because before we were saying, hey, that you should find a vector of bytes here, but it shouldn't. It's a vector of these tuples. So this underscore just says, hey, you figure it out. Whew. Okay. This is by no means ideal, right? We're unwrapping all over the place and stuff like that, but that's fine for now. We can definitely clean this up. But what we have here, which is great, is we have a vector of our dependencies, like basically mapped together with the bytes that we've downloaded from NuGet. So let's even go ahead and run this. And it's compiling because we've added some dependencies since the last time that we built. So let me see if there's any questions here. So can you explain why we need task block on? Yes. So the reason we need task block on is because Surf, which is the library that we're using for HTTP, only knows about async. It only can work with async APIs. But download dependencies here is a synchronous API. When we call download dependencies, we don't want it to return until we've downloaded every dependency. Why are we doing it that way? Well, because we just arbitrarily decided that well, one, we picked an async HTTP library. Why we did that? It's fashionable. That's why. And we get the ability to easily download our dependencies in parallel with one another instead of having to set up like a thread pool or something like that to like spin off a bunch of threads to download on different threads. We get that kind of relatively for free, so that's good. But because this is the asynchronous world, but download dependencies is the synchronous world, we need to translate the asynchronous world into the synchronous world. And that's what task block on does. It says, given some asynchronous piece of work where things might be happening in parallel because everything is asynchronous inside of it, block on this current thread until all that work is done. So that's why we need task block on. Please let me know if that helps. And you know, a less helpful but more direct way to say it is we want to call .await, and you can't call .await unless you have an asynchronous block, and you can't run an asynchronous block inside of synchronous code unless you call block on. So hopefully that helps. And it looks like the chat was also mentioning about making main async as well. We could do that, but making main async, there's async standard comes with a, async main or whatever. Basically, all it does is just generate code that calls task block on. So it's the same thing. Collect is way smarter. Yes, it is. Doesn't this mean if something fails that you'll still load all the dependencies rather than failing fast? Yes. Yes, we right now we will not fail fast, which is probably a problem, but yes. We will try to download all the dependencies even if one of them failed, only to later on then blow up because one failed. Not ideal, but we can change that in the future. So maybe I'm wrong, but since you are not using toml map, you can delete the explicit dependency. Yes, we can. We can do that. Go here, not cargo lock, and delete that. Cool. Good one. Ah, yes, there's a try join all. Maybe we should have used that instead. But hey, we at least got some good learning out of here about collect. So try join all instead of join all basically does the fail fast, where if one of them fails, it will just stop trying to get the rest of them, which is definitely what we should do. Let's just change that real quick. Try join all. And now this should be a result of vector. Like that, and then we don't need this whole shenanigans anymore. Good job, chat. Cool. Real quick, it's 6:25 in the evening, my local time. I planned on finishing at 6:30 in the evening, my local time. So we're at the end here for me, unfortunately. I hope this was helpful. We're by no means done. What we have to do now, of course, is take all the bytes that we've gotten and unzip them, and then and put them somewhere on disk in an appropriate place, and do all that jazz. But at least we've gotten to a good place. We've explored a lot of things. We've explored asynchronous programming. We've explored a CLI, tool chain. We've talked a lot about ownership and stuff like that. I hope this was helpful to you. Please do let me know if you would like to see me conclude this on stream, or if I should just go ahead and finish this on my own sometime. But if you would like to see me finish this up on stream, please let me know. Let me do my shameless plug real quick for my Twitter. This is my Twitter, twitter.com/Ryan Levick, Ryan_Levick. Please follow me if that's what you're into. And that's where I announce all my streams, so that's pretty helpful. Or of course you can follow me on Twitch. I hope that this was good for you. We're going to finish up. I'll take any last remaining questions that you might have, and then we will call it an evening for now. So any more questions? Did you have to do anything special to get Rust on Windows? So I'm on a Mac right now. It happens to be that what we're doing in this one exercise, it doesn't matter what operating system you're on. In the future, I probably will do some Windows specific programming. Rust works pretty well on Windows. When I program on Windows with Rust, I usually do it in the native Windows environment with PowerShell or whatever, using MSVC. And I don't use WSL for Rust programming normally, because if I want a Unix thing, Mac usually works fine for me, unless I specifically want a Linux environment that I might might do it. And it works quite well. And if it doesn't, then we should do something about it. So let me know if you run into any issues there, so we can see if we can get that fixed somehow. Yeah. Great, thank you. So it looks like some people want to see how this ends. So yeah, in the future, we'll probably go ahead and stream. It might be tomorrow, because I really actually need to get this done. So it might be tomorrow, same-ish time, for another 2 hours or so, and see if we can finish this up. And yeah, we'll post this on YouTube, and appreciate everybody. Please let me know again if you have any feedback or anything like that of how I can improve this. And otherwise, yeah, I really appreciate you coming out to watch. So thanks a bunch. See you around.